This problem here, we're going to look at real number solutions of an equation, and I think we're going to do it by factoring by grouping. So the first thing we're going to look at here are some ways to factor this. There's no quadratic formula for equations that have a cube root. So we're going to try to simplify this by grouping. There's no sums of cubes or difference of cubes, so there's nothing like that. The best way to do this would be to look at these first two terms and then look at these last two terms and see if we can do some factoring here. Common factor in these first two terms would be x squared. So if I pull an x squared out, I get an x, right? X squared times x equals x cubed. And I have an x squared out here, I'm going to get a minus 5 there. Okay, so clearly x squared times x is x cubed, x squared times minus 5x is minus 5x squared. There you go. Now with the next two terms, what's in common? No x's are in common, but the 5 sure is. So let's pull out a 5. I know I can pull out a 5 out of 5x and leave behind the x. I know I can pull a 5 out of 25 and get a minus 5 there, and this is how these often work out. Now I've pulled out two factors from these two terms, a factor from this two terms, and now they have a common factor in x minus 5, so I just simply write it like this: x minus 5, x squared plus 5. So here is our factoring, but we are not done. We do have to look at finding all the solutions. So if this is equal to 0, I still have to solve this further. To find the solutions, since any one of these things in parentheses being 0 would make the whole left side of the equation equal to 0, all I then need to do is solve each one for 0. So if I set x equals 5 equal to 0, remember I'm just going to look at this one and ignore completely this one for now, because whatever this one is, if x minus 5 equals 0, the whole thing is 0, and this solution will work. Okay, so that's pretty easy. Move the 5 over and we get x equals 5. That is certainly a real solution. When x equals 5, think about it. This is 0. It doesn't even matter. I wouldn't waste my time calculating what x squared plus 5 was when I plug in a 5 there. But when x is 5, this is 0, the whole thing's 0, so that's a solution. I hope we understand that. A lot of students still struggle with that concept. Now I've set the other one equal to 0. By the other one, I mean this factor. Now this time I'm going to ignore the x minus 5 one. I'm going to see what happens. Can I make this thing equal to 0? X squared plus 5 equals 0. And let's solve for that. Move the 5 to the other side, and I get x squared equals minus 5. I would take the square root of both sides, and when I do that, don't forget that I have to take the plus or minus of a square root. Okay, and oops, I got a problem here. The reason I did this was to get the x out from under the square root of x squared. But whenever I get this, don't forget your plus or minus. But whenever I have a minus under the radical, okay, really that's the square root of 5. And in other math classes, they would call it I, because I is the square root of minus 1. It's an imaginary number. You've now got an imaginary number here, but we're not worried about that because we are saying there is no other real solution with this factor of the polynomial. No real solution for this part. The only reason I said other, I'm abbreviating solution here. That stands for solution. Okay, but no other real solution. This one gave us a very real solution, so that's your only answer. This one here didn't give us any real solution. It did give us a complex or an imaginary solution with the square root of a negative number. So you're done. X equals 5 would be the answer, but you've got to know how to factor polynomials by grouping. So I grouped these two, and something very nice happened here. That's the whole key to the problem.